every type of moon formation. Space is complicated. We make it simple. Every moon in the solar system got where it is through one of a small handful of violent, chaotic, or quietly strange processes, and no two categories on this list produce a moon the same way. Some moons are captured strangers. Some are literally chunks of their own planet, blasted into orbit. Some formed alongside their planet like siblings, and some are actively falling apart right now on a countdown that started the moment they arrived. We're going in order from the calmest formation process to the most catastrophic, then we'll sort them a second way, by which moons on this list are actually stable long term, and which ones are living on borrowed time. Co-formation from a circumplanetary disk. We begin with the calmest, most orderly formation process on this list, and also the one responsible for the largest, most organized moon systems in the solar system. When a giant planet like Jupiter or Saturn was forming, it was surrounded by its own miniature disk of leftover gas and dust, spinning around the young planet the same way the larger protoplanetary disk once spun around the forming sun. And just as planets condensed out of that larger disk, moons condensed directly out of this smaller planet orbiting one. Here's the fact that should genuinely bother you. This process explains why Jupiter's 4 largest moons and Saturn's major moon system orbit their planet in such remarkably neat, orderly, roughly circular paths, all close to the planet's own equatorial plane, a level of organization that isn't a coincidence at all, but a direct fossil record of the flattened, disc-shaped environment they formed inside. Here's the part that lingers. This same process means the largest moons in these systems formed closer to their planet in the denser, warmer inner regions of that circumplanetary disk, while progressively smaller or more chemically different moons tend to have formed farther out, a size and composition gradient still visible in the current arrangement of moons around both planets today. The giant impact formation of Earth's moon. Here's the twist. Not every moon formed gently alongside its planet, some were violently ripped directly out of it. The leading scientific model for the formation of Earth's own moon proposes that a Mars-sized protoplanet, informally named Theia, collided with the early Earth roughly 4.5 billion years ago, an impact violent enough to blast a massive quantity of vaporized and molten debris from both bodies directly into orbit, where it rapidly cooled and coalesced into the moon. Here's the fact that should genuinely bother you. This single catastrophic collision is the reason the moon's overall composition so closely matches Earth's own outer layers, while lacking the dense metallic core Earth itself has. Strong evidence that the moon formed predominantly from Earth's blasted out crust and mantle material, rather than being an entirely separate, independently formed object. Here's the part that lingers. The same impact that created our moon is also believed to have tilted Earth's own rotational axis and dramatically sped up its initial rotation rate, meaning Earth's 24-hour day, its seasons, and its large stabilizing companion in the sky are all, in a very real sense, the direct ongoing legacy of a single violent collision that happened before the planet had even finished forming. Gravitational capture. Here's the reframe. Some moons weren't formed near their planet at all. They were simply passing by and never left. Gravitational capture occurs when a smaller object, often a former asteroid or Kuiper Belt object, wanders too close to a planet's gravity and gets permanently trapped into orbit, rather than continuing on its original independent path through the solar system. Here's the fact that should genuinely bother you. Successfully capturing an object this way is actually surprisingly difficult under normal physics, because an object arriving on a simple, direct gravitational path would typically just swing past a planet and continue onward, unless something specifically slows it down at exactly the right moment, meaning captured moons usually required an unusual assist, such as a close encounter with a third body, or significant atmospheric drag during an early denser phase of the planet's own formation, to actually lose enough energy to get stuck in orbit. Mars's 2 small, irregularly shaped moons, Phobos and Deimos, discussed elsewhere on this channel, are widely believed to be captured asteroids based on their composition and lumpy, non-spherical shapes, rather than objects that ever formed in a neat, organized disk around Mars the way Jupiter's largest moons did. Here's the part that lingers. Captured moons often end up on unusual, sometimes unstable orbital paths compared to co-formed moons, a direct signature of their chaotic, accidental origin rather than an orderly, disk-based birth. Fission from a rapidly spinning parent body. Here's the fact that reframes an old, mostly abandoned theory that turned out to be correct for at least one confirmed case elsewhere in the solar system. Fission proposes that a moon can form when its parent body spins fast enough that centrifugal force alone tears off a piece of material directly, which then settles into its own independent orbit around the remaining, now smaller parent. This exact model was once seriously proposed and later largely discredited as an explanation for Earth's own moon before the giant impact model described earlier became the dominant scientific consensus. Here's the fact that should genuinely bother you. Fission does appear to be the correct explanation for at least one confirmed case. The dwarf planet Haumea, discussed elsewhere on this channel, spins so rapidly, once every roughly 4 hours, that its own elongated, stretch shape and its family of similarly orbiting icy fragments are widely believed to be the direct result of exactly this kind of rotational fission, likely triggered or amplified by an ancient collision. Here's the part that lingers. Fission requires an extraordinarily specific, narrow set of conditions to actually work, which is precisely why it remains a rare, exceptional formation process on this list rather than a common one, confirmed for only a small handful of unusually fast spinning bodies, rather than functioning as a general purpose moon making mechanism across the solar system. Collisional debris disks around smaller bodies. Here's the fact that pushes the giant impact concept to a dramatically smaller scale. Earth's moon isn't the only object believed to have formed from the debris of a violent impact. Smaller bodies throughout the solar system show evidence of the exact same basic process playing out in miniature. Pluto's large moon Charon, discussed elsewhere on this channel, is now widely believed to have formed from a massive ancient collision between Pluto and another large Kuiper Belt object. Similar in overall concept to the Theia impact that formed Earth's moon, just occurring much farther from the sun and involving smaller, icier bodies. Here's the fact that should genuinely bother you. This specific formation process directly explains why Pluto and Charon share such an unusually close, tightly linked orbital relationship, technically orbiting a shared point of gravity that sits in the empty space between them, rather than Charon simply orbiting around Pluto the way a typical moon orbits its planet, a relationship discussed elsewhere on this channel as closer to a double object system than a standard planet and moon pairing. Here's the part that lingers. This same basic collisional process, scaled to whatever size the objects involved happen to be, may be responsible for a meaningful fraction of smaller moons throughout the outer solar system that don't cleanly fit the neat, orderly co-formation pattern seen around the largest gas giants. Ring accretion and moons forming from a planet's own rings. Here's the fact that closes the loop, connecting this entire list back to an earlier video on this channel. Some small moons appear to have formed not from a giant impact or a captured wandering object at all, but by slowly accumulating directly out of a planet's own pre-existing ring system, gravity gradually clumping ring particles together into a solid body over time, essentially running the entire ring formation process, discussed elsewhere on this channel in reverse. Several of Saturn's smallest, innermost moons show physical and orbital characteristics consistent with having formed this way, condensing directly out of material at the outer edge of Saturn's ring system rather than arriving from elsewhere in the solar system. Here's the fact that should genuinely bother you. This means the boundary between a ring and a moon isn't actually a fixed, permanent distinction at all. It's a description of a single object's current stage in an ongoing physical process, since orbiting a planet slowly clumps material together into new moons at its outer edge, at the exact same time that tidal forces are, in some cases, tearing existing small moons back apart into fresh ring material closer in. Here's the part that lingers. Several of Saturn's small moons discussed elsewhere on this channel, including the moon shaped like a ravioli from sweeping up ring material as it orbits, are living proof that this exact process is still actively happening today, not something that only occurred once, billions of years ago, and then stopped. Moons formed from the debris of a destroyed larger moon. Here's the fact that closes this list on its most destructive, most cyclical note. Some moons may not be original formations at all, but the reassembled wreckage of a previous moon that was destroyed. Neptune's large moon Triton, discussed elsewhere on this channel as a captured object on a slow collision course with its planet, orbits backward relative to Neptune's own rotation, a telltale sign of capture rather than co-formation, and models suggest that Triton's arrival may have gravitationally disrupted and destroyed any pre-existing moons Neptune already had at the time, scattering their debris into new orbits or flinging it out of the system entirely. Here's the fact that should genuinely bother you. This same destructive cycle is expected to eventually repeat itself in the future, since Triton's own slowly decaying orbit will eventually bring it close enough to Neptune to be torn apart by the planet's own gravity, likely forming an entirely new temporary ring system that could, over a long enough timescale, potentially reaccrete into an entirely new generation of smaller moons. The same basic ring to moon process described in the previous entry, but running as the final chapter of a moon's entire life story rather than its beginning. Moons formed from a parent star's protoplanetary disk directly. Here's the fact that closes out the formation categories with the strangest possibility on the entire list: a moon that never actually orbited a planet's own circumplanetary disk at all, but formed independently, alongside its planet, from the same original raw material. In this scenario, sometimes proposed for a small number of unusual moon-planet pairs, both objects condense at roughly the same time from the same regional patch of the larger protoplanetary disk surrounding a young star, ending up gravitationally bound to each other as a package almost from the very beginning, rather than one object forming first and the other arriving or condensing around it afterward. Here's the fact that should genuinely bother you. Distinguishing this formation pathway from ordinary co-formation around an already formed planet is genuinely difficult, since both processes can leave broadly similar chemical and orbital signatures, meaning astronomers studying certain moon systems, including some unusual pairings discovered around exoplanets, still can't always confidently say which of these two closely related processes actually happened. Here's the part that lingers. This category blurs the line between moon and binary planet almost as thoroughly as the Pluto-Charon system does, raising a genuinely unresolved question about whether some of these pairs should be classified as a planet with a moon at all, or as two planets that simply happen to form locked together from the start. Let's sort these 8 again, a different way, not by how they form, but by which ones are actually stable long-term and which are living on borrowed time. On the fully stable end, moons formed through orderly co-formation, still occupying essentially the same well-organized orbits they settled into billions of years ago, with no known process currently threatening to disrupt them. On the confirmed but slowly drifting end, Earth's moon, the product of a single ancient giant impact, currently stable but very gradually drifting farther from Earth over time, as discussed elsewhere on this channel. On the inherently unstable end, captured moons like Phobos, whose accidental chaotic origin often leaves them on orbits that are, by comparison, less naturally stable than a co-formed moon's neat circular path. And on the actively doomed end, Triton, a captured moon on a confirmed slow collision course with its own planet, destined to eventually repeat the exact same destructive ring-forming cycle that may have already claimed whatever moons existed around Neptune before it ever arrived. It's worth being clear before we close about how astronomers actually distinguish between these formation histories after the fact, since nobody was around billions of years ago to watch any of them happen directly. The main tools are composition, comparing a moon's chemical makeup to its parent planets; orbital geometry, checking whether a moon orbits in the same direction as its planet's rotation and close to its equatorial plane, as co-formation predicts, or on a tilted, backward, or highly elongated path, as capture predicts. And, where samples exist, direct isotopic analysis, the same technique used to confirm the giant impact origin of Earth's own moon from lunar rock samples. Here's the fact that should genuinely bother you. For the vast majority of moons in the solar system, we have only orbital geometry and remote composition estimates to go on. without a single physical sample in hand, meaning several of the formation histories described in this video remain the current leading theory rather than a fully settled, sample-confirmed fact. Here's the last thing worth sitting with. Every moon you've ever looked up at on any planet arrived through violence, coincidence, or the patient, orderly physics of a planet's own formation, and in several confirmed cases is either the reassembled wreckage of something that came before it, or is itself destined to eventually be torn apart into the raw material for whatever comes next. A moon isn't a permanent fixture of its planet's sky. It's one stage in an ongoing, occasionally repeating story. Not bad for stick figures on a rock,